Hi guys, welcome to the MathSpellBook live stream. I'm your host Peter, and we are going to get back into differential equations today. Hopefully you guys are having a good Wednesday. You made it to the middle of the week, so congratulations to you guys. Hopefully you guys still have hair on your head if you were having a stressful week at the beginning, but hopefully it's all like I'm thinking of this expression that I think Jeremy Irons used in the movie. I think it was called Margin Call. It's like, it's all spilled milk under the bridge. I don't know if that's the exact quote he used, but we'll go with it. So I think we were still struggling with this one problem, so maybe we should like actually try to get this problem done, and then we'll probably move on to like the textbook that I want to get into. So we were still doing we were doing inverse linear transforms. So now we got to figure out how to do this problem. Now, yeah, it doesn't look like any problem we're familiar with unless we switch it around. So maybe we have to do let me see here. So let's do this, because I have an idea. I don't know if it's gonna work, but let's do this. And then maybe that might help us, but we still have an S on the top. Unless maybe we should do this instead. I was thinking of something else. So maybe we can do this instead. Do this, but then we'll take. Then that would be positive. This would be negative. Yeah, that looks about. Okay, so that looks like it could be something we can do. So maybe like that, and then this will be plus, so 3. Maybe we have to do a fraction here. So yeah, I think that would probably be what we have to do. So it will be 3, 5, because I remember we got tricked the last time with that. So and I think that is the answer to what we were looking for. Oops. Oh, this is the inverse transform. So it has to be ft. Because it seems like all the puzzle pieces fit. Let's take a look at the solution and see if it is. Let's see, this is in letter F, right? So That is correct. Cool. We managed to solve that one. That one was actually a pretty challenging one because we had to like move the negatives out. But luckily we managed to get it. Awesome. Let's see here. Alright, so I think what we can do is go into here. So this is the textbook I actually want to use to challenge myself a little bit. So problems 1 to 8, determine all the solutions, if any, to the given boundary value problem by first finding the general solution to the differential equation. So this one's just regular differential equations, it's not partial yet, because this section is on partial differential equations. So let's try number 1. So we'll just get all that, allow, then we'll move it over here and expand it, like so. Okay, so now that's equal to 0, and that's equal to 4. Okay, so we got minus, meaning that if we have m squared equals 0, we are left with m minus 1, meaning that m is equal to 1 and m is equal to 0. So we have, well, technically we have 2 of these, so meaning we're going to have to make y equal a, well, technically it would just be a, and then plus b to the x. And now we have to follow the conditions here. So x can be between 0 and 1. So if we have y at 0, then it has to be 0. So then we have a plus b. That means a is equal to b, or a equals minus b, actually. And we also have that y1 is equal to negative 4. So we have 4 and a actually, let's make b equal negative a, because I think that would make it less cumbersome to deal with. So we have a minus a times e times e. So we can just factor out a, giving us 1 minus e, and then 4, meaning that a is equal to 4 Okay, so given that y is equal to 4 over 1 minus a, 1 minus e, and plus b b is equal to negative a, which means that this is equal to the same thing, only the negative version times e to the x. I mean, that looks about right. I forgot to bring up Quizlet, so let's bring Quizlet out. Drag it down here. Put it right here. Well, actually, next to the textbook. Then we'll go into our library, folders, physics. Here we go. And we are on chapter 10.2. So number 1, we have this solution. Got the 4 part right. E minus E. Now, what did I do wrong here? Hold on. Oh, it's minus 4. Oops. This is plus. Let's see, arbitrary. Oh, dang! I mistakenly thought that was a derivative. Oops. That's why it's off. Okay. It has to be 1. That's why it's off. Okay. See, sometimes I make like this, like the smallest mistakes that cost us big. That's why it's wrong. Okay. Okay. Let's erase all this. So technically it's supposed to be like this, and then plus and minus. That's why it was off. So then we have a minus x and b x. And the conditions we have, make sure we do it right this time. So the conditions we have are y equals 0, and when y is equal to 1, it's negative 4. Okay, now let's do this correctly. So we have 0, and when x is 0, that case, now we're gonna go for well, actually, let's take that out and then put -4, and then this is gonna be E. Just pure E, and then have plus so in that case, so we do this, then B, so let's just multiply that. And B is equal to -E. So if we do this, then A would be -B, so then we're left with A I think I did something off. Let me just see something here. Let's see. Oh yeah, because we have the E's, I forgot. So in this case, plus, well actually it should be minus 4 to the E, or I mean, they did it a simple way. I was just trying to do the, I guess, the typical algebra. Alright, let's try number 2. Alright. Here we go. So we have y prime, 6 prime, y, and then I think we know where this is going. Now we have y is equal to plus x, and then 5x. Okay, next we gotta do equals 1. So 1 is equal to 1a plus b, and when y is equal to 2 equals, it also equals 1. So we have a, and then that would be e to the 10th. So now we're gonna have to do, oh hello, Deku Spoon. Awesome name. I want to learn differential equations. Same here. I'm actually trying to teach myself how to do it. So I guess we're doing linear. I guess we're doing like basically just replacing stuff. So I guess we'll minus. B to the 10th. Like, are you trying to teach yourself differential equations, Deku Spoon? I see. Like, how far did you get into studying it? Sheesh, Ace. Looks like it's a big... it looks like it's a big mess. It's just nothing but ease. I was sick the day our teacher taught it. Oh, I see. So, what classes are you taking, actually? Are you a university student, high school student, or graduate student? Well, I copied the lecture notes and have a ton of exercises. Oh, okay. Yeah, always practicing with exercises is always good. I don't even know if we're doing this right. Because like that solution for A looks kind of scary. But then again, it's just a bunch of E's. Plus B. Meaning that B is going to be equal to 1 plus so oh man, this equation looks, I mean, it's not bad, it's just very, very, like, very, very out there. But then again, not all equations are supposed to look very, very elegant looking. Oh, that's way too small. We need to make more space. I'm in uni. Oh, okay. What are you studying? Engineering, physics, mathematics, bio, chemistry, computer science. I don't think I can list all of them. Unless you're doing math as a, like, unless you love math but you just want to, like, just do it as a hobby. That's also a possibility. Not 10 to the 10. Yeah, that looks like a really massive mess. I mean, I could simplify it, but I feel like simplifying it will just basically... I mean, we could put this E over here. I just feel like I don't want to. We got the bottom right. Yeah. Oops. Oh, they just rearranged it. Okay. I sometimes don't do that. But it looks like... Eats the second. I mean, if you did it like that, let's just... because these two will cross out. Okay, yeah, we could have simplified it more. But, pretty much that basically is it. We just didn't do a single step. So there was a way to simplify it. I just was kind of too lazy to do it. I admit it, there are times when I just get lazy whenever I work on a problem sometimes. I grab my notes as a great opportunity to study. Yes, actually. Like, that's what my streams are for. Like, you know, if you guys like physics, mathematics, or you just need a study stream to keep yourself productive, like, you know, if you're watching this on YouTube, you know, hit the subscribe button, as well as like hit the like button. And if you watch this after the live stream has like aired, care to drop a comment down below. Let me know what you're working on. If you're watching this on Twitch, if you like math and physics, or you just need a study stream to keep yourself productive in front of your computer, just drop me a follow. Keeps me motivated to continue doing these math live streams for you guys. Okay, so let's continue on. So I think with these, we're okay. Let's try these. Problem 14, 9 to 14. So I don't think I've ever experienced doing this one yet, so I think it would be a good opportunity to try it. Expand this. Okay, find the values of lambda, the eigenvalues, for which the given problem has a non-trivial solution. Also determine the corresponding non-trivial solutions, the eigenfunctions. Okay. I've never worked with these type of problems, but we'll give it a shot. We'll give it a shot. So apparently we have. So this would be, but then we have a lambda here. So oh no, that's supposed to be a 1. So it's just purely lambda. That equals 0. Oh, we're gonna have an imaginary solution. Yep, we're gonna have an imaginary solution here. Meaning that we're gonna have 1 plus or minus lambda. Okay. Which means that the way the solution is set up would be, so there's no real part, so there's no e, so we have a plus cosine of lambda x, and then plus, oop, that's supposed to be sine of now the question is that when it comes to this type of scenario, does one of them have the negatives in it? We have to take the derivative here. So if we have a derivative dy, that means it would be a times lambda sine, negative sine of lambda x plus b times lambda square root of lambda cosine of lambda okay. So the thing is that we gotta figure out what lambda is. So when did 0, so all of these have to be 0. So when cosine is 0, then that means this is 1. But this has to be 0, so if it was 0, then basically sine becomes 0, and this b would come 0, and this. So basically lambda has to make it so that when this is 0, it has to like not be 0 in some way, which I don't think we can do, because we're gonna still have x, and x is gonna basically make it 0. So there's no way we can actually stop the 0 from making the cosine not 0. I mean, yeah. I mean, I have worked with eigenvalues before. It's just doing it within differential equations is going to be a little bit interesting, because I'm so used to doing eigenvalues with like matrices, but with differential equations, I think we might need to have to look up some things, which is usually the fun part sometimes. So all these have to be 0 when we have pi involved, which means, I mean, cosine, we have to make sure that cosine, when it comes to pi, maybe if we figure out with this one, because now we know that x has to be pi, so and it has to be in here, so we have to make sure that when it's basically when it's pi, we have to get it so that it doesn't give us pi in for cosine. So maybe if we solve this part, we'll be able to solve for this. Solve for this, I mean. So let's try it, shall we? So in order for this to not pi, we're going to have to maybe we should have lambda equal 0.4, because if that is the case, let's see if that works. So if we have this equal to, then that would be 0. So then this would go away, and then we have sine, that would be 1. But this has to equal 0, so I don't think we're on the right track here. Because we have both cosine and sine here, so I don't think there's any way to make them zero, like simultaneously. Because the way they behave opposite of each other. So that means A and B has to be zero. If that were the case, which is non-trivial. I mean, it's not non-trivial. Because it's kind of a trivial solution at that point. Because there has to be something else that makes everything zero. Unless lambda is supposed to be zero. Oh, go ahead, Deku Spoon. Nah, I don't really think it's a dumb question if it's like related to the topic you're learning. Like, what's the question? I'm not a teacher, by the way. I just basically like doing math for fun, so whatever I give as a reply, you know, like sometimes it's a bit of a, how should I say? I would say take it with a grain of salt sometimes. That's what I'm saying. How did you do the second equation? Oh, you mean the derivative here? Are you talking about this one? This equation? Actually, Deku Spoon, do you mind if I ask where you're from? If you don't want to reveal that, you can just basically say, I don't want to reveal that. And it's understandable. Because I think, like, whenever I ask that, when anyone finds me on YouTube, they tell me they're, like, from India or somewhere else. Majority of them, they would tell me they were from India. That's why I'm curious. Oh, okay. So, the way I did it is that when you take the derivative of a sine or a cosine function, like this. So let's say we have sine ax, right? So the thing of it is that we have to take the derivative of x here. Tunisia. Tunisia. Oh, okay. Yeah, I'm not familiar with that country. Like, where is that at? Hopefully I pronounced the country right. Dick Spoon. Tunisia. I feel like I want to Google that now. Oh, in North Africa. Wow. Well, welcome to the YouTube live stream, Deku Spoon. I don't think I've ever talked to anyone from like North Africa before, or Africa, to be honest. I think I have like whenever I streamed on my other channel, I think I did talk to someone that was from Egypt at one point. You're welcome. So anyway, back to your question. Before I lose track. So the way you differentiate like a sine or a cosine, so we'll do it like one by one. So we'll make it the same structure so it looks fine. So the thing of it is that you have to do something which is called the chain rule. So I believe it's called the chain rule. you have to basically try to differentiate. So, because we know that the derivative of sine, so let's actually write the regular derivatives first. So, so we know the derivative of sine x is cosine x, and the derivative for cosine is negative sine x. But we have a little constant here, and we have to figure out how to differentiate that within this thing. So the way to do that is that you have to kind of try to transform this into something else. So I believe it's called the chain rule. So we basically try to transform it by turning it into a u, and then we try to differentiate that. So we know that if you take the derivative of just x, it's just 1. But if you take the derivative of, say, like a constant x, like the derivative of x is 1, so it's the same thing as basically saying this, which will lead us to just being that constant, or that number. So in this case, we have the derivative, so we have to take the derivative of u, which is this, so it's du dx, and then taking the derivative of that, we basically are given we're given a in that case. Okay, so because we did that, now you have to multiply this with the derivative here. So so we have sine, we'll just write it over. So then we'll do the u trick, which will turn that into u, and then take the derivative of that to x, which is a. So then we are then given that a multiplied by the derivative of, turn this into du dx, because sine is now u, like so. Well, hopefully my explanation, hopefully you're able to follow my explanation. If I'm going too fast, please let me know. And then you have to take it as if it's just a regular sine. So the way we did it, like here, because we derived it from x and it's just x here, we have to derive it from u because u is here. Okay. Did I write this correctly? Oh no. So the way I wrote it didn't look right. So du dy. Okay. So when that happens, we just turn this into cosine of u, but we know what u is, so that turns into a cosine of ax, and that's how you get the derivative of that. Your explanation is excellent. Oh, well, thank you. I mean, I tried, but I felt like I was kind of like going all over the place with there, because even though I like tutoring, like I haven't tutored math, so I try my best to actually like go where the student is, like, because I don't know if you know any of the stuff that I know, so I try to backtrack and I try to say like the basic stuff like as clearly as I can to show all the steps too, because I know when you skip steps some students get lost. So yeah, hopefully that helps. Because usually you practice like the basic derivatives first, and then you get them, like the more you do it, the more you kind of memorize them. And then eventually you start doing like much more complicated derivatives, but then they become much easier because you can just move them around. Like, I mean, you can move around the constants that don't belong there, or you can take out an x where it's not supposed to be there. It's the same thing with integration. Integration I have to practice more actually, because I've forgotten a lot of tricks with integration, such as I think trig substitution, and what else? I think like most of the trig functions I in integration I kind of forget. Okay, so yeah, hopefully that helps. Hopefully that helps, Dexter Spoon. I'm guessing you're taking Calculus 1 because like you're trying to learn this stuff, or is it like in the differential equations problem that you're dealing with, involving like differentiating with trig functions? But that was a pretty good question actually, because some people don't even know what it means to take a derivative of something. Because a lot of my friends don't like math, and if they saw this, they'll be like, what does this mean? Why are you doing this? You know? I mean, math kind of get, like, when you like math and you're the only one in your friend group that likes it, it kind of gets a little lonely sometimes. But at the same time, it's like, I feel as if, like, you're doing something that a lot of people are not willing to do, which is like challenge yourself and constantly face the fact that you don't know as much as you think you know. I'm in vacation, so I didn't revise much. Yeah, that's fair, especially if you're like especially when you just get tired from school and stuff. And I love math too. Cool. Yeah, because I love math because of physics, and I love physics because it makes a mathematical framework of the physical systems that it describes, which I really like. So maybe I have to look up the chapter involving eigenvalues and eigenfunctions. Hey Famish, how's it going? So let me take a look at the index. Where do they talk about eigenvalues? Eigenfunctions. Eigenspace, eigenvalues. Here we go. Do they have to be complex though? Distinct. Okay. 531. Let's see. Complex eigenvalues. Maybe it might be in this part of the chapter. Distinct eigenvectors, here we go. That's what I'm looking for. Homogeneous linear systems, okay. I'm just chilling, wondering if I should go get coffee or get lunch instead. I mean, how much time do you have to get lunch or coffee? Like, do you have to, like, are you like on a strict schedule or something? If you don't have much of a time crunch, I would say get lunch. That way you can get what you want. That way you can get like something nice for yourself to eat. But if you're on a time crunch, like maybe just get coffee. Not really, but I want to get to work. Oh, okay. If you need a good meal, I would say get lunch. Okay, so let's take a look at this. Homogeneous linear constants. Yeah, the lunch will probably be best. Yeah, because you don't want to go like working on an empty stomach. Okay, so it's similar to the way we arrange vectors and matrices. But how do you do that with, okay, here we go. Eigenvalues and eigenvectors. Yeah, that's practically the definition we got. Corresponding to non-trivial solutions, U, are called eigenvectors. Okay. So we got a matrix A. Yeah, this is what we got used to. And then when we get the eigenvectors, hence the eigenvalues are 1 and okay. To find the eigenvectors corresponds to r equals 1. substituting A and R1 gives then we gotta do it for R2, which is negative. Question is, how do we do this with okay, linear independence, eigenvectors. Suppose that an n by n constant matrix is linearly independent. Eigenvectors, let the eigenvalues correspond to the fundamentals. Now this is basically going back to what we learned in linear algebra. Since the eigenvectors are assumed to be linear independent, theorem 1 in section 9.3 that the determinant of the basis vectors is not 0. Hence, the Wazinskian is never 0. This shows that where's 12? That shows that 12 is a fundamental solution set. Coincidentally, the general solution by 13. Okay, so basically the determinant cannot be 0 in this case. Okay. Now, the thing is that how do we, let's see, linear independence, or if our distinct values for the matrix A and U is the eigenvector associated with Ri, then U1 to M are linear independent. Now the question is that how do I do this for like differential equation? Because our question is, we got this, and now we got to figure out what the eigenvector is in this one. Hey, Balika. Nice to see you. Yeah, nice to see you again as well. Still doing second order ODEs. Yeah, a little bit. We're trying to expand on it a little bit more. But how are you doing, Balika? What's the best part of your day so far, my friend? I think of streaming my progress, and I have to figure out the mic issue as I have a background noise. I think you might have to figure out what type of mic you have. Hey, Sascha, how's it going? Saw you were doing diagonalization. Well, I'm actually trying to figure out how to implement it with differential equations, because apparently I saw this interesting question here, or interesting section in this book. Let's go back, because this is the chapter on partial differential equations, and I thought I would just dip my feet in it a little bit, because this section actually shows you how to do the, what is it, the method for separation variables, and I was like, oh, Oh, that's interesting. But in the middle of it, while they're having you solve a second order differential equation with a lambda in it, they need you to do the eigenfunctions and the eigenvalues. And I'm like wondering how you set that up for a differential equation. But what's the best part of your day so far, Sascha? Best part of my day was listening to a video on the Basel problem in the gym. Oh, nice. I can't really study while I'm like working out. For me, I just want to get my exercise done with, and then I can just focus my energy on just actually reading stuff involving math. But that's cool that you're able to like work out and like listen to like math content. For me, I can't do that because I usually do all my exercises through videos, so I just have to watch the videos of my exercises, and then I exercise with workout videos, so I have to work out like while watching someone else work out. If that makes any sense. Yeah, so how do we turn? So I think we gotta go back to where we were. Oh no, we have to do this one. Okay. So now we gotta figure out how to incorporate this into, do we know the sign of lambda? And no. So the thing of it is that I think in this problem, you have to figure out what lambda is. At the same time, you also have to figure out what the whole equation is. Which is, but you're gonna have to do something involving that. So for PDEs, this is a bit different from what I showed you because the operator are acting over an infinite dimension vector space. But nevertheless, the idea is the same. Find a nice basis for your space, and that consists of the eigenvectors. Okay. I think it's because like this is a transition between like actually doing something that involves linear algebra and something that involves differential equations. Because like I think if I had a matrix, I basically would be like, oh, I just have to do this and set it up for the eigenvalues. But this, we don't have a matrix. So now I'm thinking like, how do we set up a matrix for this? I think that's what I'm thinking about. Unless we have to use the what is it? The Ronzinskian, I think that's what it's called. Unless that involves that, which is what I'm trying to look for in this case. You should think of the Laplacian as if it was a matrix operator. Oh, okay. As a matrix operator, huh? Let's see, real symmetric matrix. You know, what I'm looking for is like, how do I make it so that we can get it for differential equations? Okay, what, maybe it's in the complex eigenvalue section? Maybe it is this one, because it is involving a lot of like e's and cosines. Let's see, in the previous section we showed the homogeneous, okay, differential equation, okay. Oh, so we have a derivative here, and we have a regular function here, and it's being multiplied by a, which is a matrix. Now we gotta figure out how to make this matrix. Because I know when you do the eigenvalues, you have to set it up so you have a matrix A, and then that minus a lambda and the identity matrix, and that equals 0. So the one thing is that we have just an equation here, so I have to figure out how to turn this thing into, like, I guess like a matrix, if that makes any sense. Or like how to turn this whole problem into having a matrix setup where we have like this relationship. Because that way we figure out what lambda is, and then we can just complete this process of this problem here. But I actually like this problem because it actually takes two things that are in different branches of math and just puts them together so that we can actually implement them at the same time. And that way we can remember that math technique much better. So when we were talking about diagonalization, I told you that we were looking for a linear map from F to V to V, and the point of diagonalization was to find the eigenvectors that make it very simple. I.e., if V is an eigenvector of F, we have F of V equal to lambda star V. So what is lambda star in this case? Is lambda star supposed to be like the conjugate of lambda, or is it just it's supposed to be like lambda times V, or lambda multiplied by V? I should say. Lambda is the eigenvector. It's multiplication. Okay. Okay, so yeah, because we also have boundary conditions, and these boundary conditions also have to play a part in this problem. Yeah, I think that is boundary conditions because both of them are 0. Because I think if it's an initial condition is like oh no, I think this is the boundary condition because it has to be in this certain parameter, and then we have the initial conditions between them. But I guess it counts as both in a way. Okay. Okay, I'm just rereading what you typed, Sascha, so I feel like you're trying to help me, but at the same time I know you're also trying not to give too much away. So that's why I'm trying to think about what you said, and I'm trying to think about like, okay, like how do I put the pieces together? But this is how our streams are, guys. It's like basically I struggle with a problem, and you guys, like, if you know the right technique to approach it, like you just basically give me hints, and it's like, okay, you're giving me hints, we're getting like ideas here. So the upshot is that the Laplacian is a linear map that takes a smooth function and gives you this gives you a smooth function. So it makes sense to ask the eigenvectors, usually called the eigenfunctions, and eigenvalues. Yeah, like right now I'm just trying to figure out how I can start to get the eigenvalues. So maybe hey, welcome back. I mean, if you look at this, for some reason this, what is it? Oops. This almost looks similar to this in some way. Almost. And I feel like that might be a clue, but I'm probably thinking too much into it. Because the thing is that, like, this is the second derivative, right? So Like, what would the matrix be in that case? Would it be like dy dx and then d second, oops, I probably should write that better. Like that, and then I would wonder like where would go over here or something like that. And then what would go with y in this case? Would it be like it's like, I mean, would it be the identity matrix at that point? But then what would we have over here? So if we find the basis function for the Laplacian, you will be able to write the Laplacian as a simple, is a very simple form. Laplacian, huh? So it's the second derivative. Because what I remember about the Laplacian is this is equal to that, which is f of x. So I think it's supposed. I think all of them are supposed to be the second derivative of each other. I think it's something like that. That was the upshot. Now we are in an infinite dimensional case, so the type of computation we did last time are not effective anymore. So we will have to find another way. I'm actually like quite confused on what you mean, Sascha. I'm not talking computation-wise. Oh, okay. I'm just giving you the big picture. Oh, okay. Now, how do we get started with this type of problem? Let's see here. Okay, find the general solution of, okay, so this one, they actually give you a matrix. Maybe there's a way to actually figure out how we can form a matrix in this chapter. Oh no, this is just purely like linear algebra stuff. Non-homogeneous linear systems. Matrix exponential form. Yeah, this is when eigenvalues actually, like eigenvectors and eigenvalues really shine in here. Generalizing eigenvectors. Solving. Maybe this is it. To obtain the fundamental solution of for any constant square of matrix A, well, find that for like... So all this goes into the partial differential equations course. I don't know. I guess maybe we spend so much time like looking up, maybe we should check out what the answer is. Like how they do the solution. So it's 9. Yeah, it's number 9. Okay, let's see how they did this. Chapter 1, 10. Yeah, I want to make sure that it's the right section because I think it's 10.2. Yeah, it is 10.2. Okay, here we go. Right, we did that. And then we're left with it. Okay, so at least we did this right. We got like negative lambda. I mean, I kind of turned it into I lambda, but then we wrote it like this. Show the steps, please. Yeah, that's practically the same thing we got for the derivative. So we did that section right. Yeah, the thing is that when we're trying to solve for this, we can't get x as 0. I mean, there's no way for us to turn like one of these terms not 0 in this case. Because if we turn this to 0, this turns into 1 and then we get a, but it's supposed to be 0 on both scenarios. And if we try to make one 0, the other one won't be 0. And the only thing I can think of that they can be 0 is if A and B is 0, which is a non-trivial solution. Yeah, that's what I'm thinking. It has to be like the variables, like the constants have to be 0. So y equals... So y is equal to b sine square root of lambda x. No, you use y pi to equal 0. It gives you a restriction on lambda. Yeah, because the thing of it is that like when I know that if I turn like x into something, it will transform into like the opposite for the other one. So the point is to figure out both lambda and how to actually get a and b in this case. And I'm trying to figure out exactly, is there a way to figure out what lambda is without having to do too much guesswork. So a is 0. And then b, yeah, okay, yeah, that would make sense if a was equal to 0. Yeah, that makes sense. So in this scenario, a is equal to 0. And I think for this scenario, we would have to because if we have 0, if we have pi here, then b might have to be equal to 0. Because then we would have pi, and then anything involving pi would give this 1 or negative 1. So this goes away. So now if y is equal to, if y 0 leads us to b sine, and then the derivative of then that's equal to, yeah, so that would make that a lambda sine x. Alright, so now we have to figure out how these two are 0 in this case. So let's just go down here. What did you type, Sascha? I just saw it right now. Now we are ready. We know b is equal to 0 is a solution, but that's a trivial one. The other alternative is that equals 0. Right, yeah. So we'll just write this like so, equals 0. And I mean, b is a non-trivial, is a trivial solution, so we kind of don't want that one. And if sine is equal to 0, and I mean, technically it's already 0 because we have x is equal to 0, so that means it's already 0 in that case. A is equal to 0 in all cases. Okay. Like what is it that I feel like I think like Sascha, like you're working like ahead of me, and I think that's why I'm kind of getting a little confused. Like, I get what you mean by making a 0 here, because like obviously the cosine is, when it's 0, it's just going to give us 1. So I get that part. So you find the general form of uy is right, yeah. So we got that part. Yeah. So we just have to figure out what b is, or lambda. Okay, now let's use the boundary condition. Okay. So let's just erase this, because it's just not serving us. It's not serving us at all. And we'll erase this too. Okay, so it has to be 0, while b sine of lambda, but then we're also having, so that's equal to 0, which means we're gonna have sine of 0. Right. Okay. Now let's compute the derivative of that. Okay. Okay, that's something we didn't do. So the derivative. So we'll say that y is equal to b x. So that means it will be b. Oh no, not x. Lambda. It's supposed to be lambda. Lambda. And then cosine of lambda x. And then I'm guessing we take the derivative of that. I mean, not the derivative. We'll implant the boundary condition in that one, right? So at that point, we're left with basically the boundary condition is pi. So it can either be, depending on what lambda is, and that is equal to 0. So I'm guessing because it is pi and that will give us 1, we have to figure out how we can turn this pi into 0, or at least turn this angle into 0. So cosine basically has to be, or at least lambda, it has to be equated to probably n over I don't want to say 2n though. Okay, we know so either b is 0 or lambda is equal to 0, or don't you mean yeah, that's what I thought you meant, because I was like, you put double pi and I'm like, don't you mean lambda is 0? Yeah, so basically if cosine is supposed to be equal to 0 in this case, we're gonna have to turn the pi, or make the pi go away. So now we have to figure out, because cosine becomes 0 when it's a 90-degree angle, which is pi over 2. And I think the thing of it is that so we have to find a way to get rid of the pi, but turn it into something else. So cosine equals 0, and because we know that that leads to 0, and leads to 0. So the only thing I can think of is that yeah, exactly. You're making good progress. Yeah, because I know it has to be a very general solution for lambda in this case, because if we make lambda equal like 1 over 4, that doesn't account for a third over 2. So in general, like pi over 2 plus pi n, where n is an integer. Let me see. Maybe that could work. Pi over 2 plus pi n. So 2 plus pi n. That all times pi? Or am I just misinterpreting what you mean? Because I know we have a pi outside. That's why I'm thinking about doing things like 4 of a pi, like I was just telling you when cosine is vanishing. Yeah, because I know I have to do a general solution. That's why. But I'm thinking of, because the solutions I'm thinking about are very particular, and I know that's not the way it's supposed to be written. Because I know that this would get us like what 4 over, like, yeah, 1 over 4 will get us this result. But then I have to remember exactly like what will get us this result. And okay, so first, you said 1/2 plus pi n, right? So I'm guessing maybe if pi is multiplied to lambda, or at least the square root of lambda, yeah, if it wasn't for the square root, it wouldn't be that it wouldn't be that much of an issue. For some integer n, so now you can solve for lambda. But this is like everything including pi and lambda together, right? Like this part? Is that like basically with pi multiplied into lambda, the square root of lambda? Okay, I think it's because I saw so many letters. That's why I didn't think of it as an equation. My bad. That makes a lot more sense. Okay, so now we can solve it, yeah. So then we can factor out pi, 1 plus n, and then we can divide it into, there we go. Dang, I hate it when I run out of space. So then we'll just move it over here. So then we have lambda, square root of lambda, which equals, meaning that if we multiply this, then lambda is equal to just that. Okay, so that means that, y, now we have to actually solve for a and b. That's going to be quite a feat. So a plus, well, technically we can just write this. Yeah, we can just technically write this. that plus sine at this point you're done. Any real number, we cannot solve for b. So technically this would be the whole thing, right? Hello, Yab from YouTube. how are you doing? What's the best part of your day so far? But a is equal to 0. What is the application of such an equations? Well, it's a differential equation, so like depending upon what rate of change you're dealing with. So I'm guessing because it has a sine and a cosine function in it, you can think of it as like something involving waves or something involving signals. So I think that's the only, because I am not fully equipped with STEM knowledge, so I'm not sure exactly where this could apply to, but maybe it could apply to something that involves like periodic stuff, like say like a periodic wave, or maybe like a specific type of curve that repeats on itself. Like it could be something like that. You're doing good? That's good, that's good. I mean, hopefully that works, because usually hopefully that helps, because let's see, evolution of temperature in a rod for this equation, Sascha. So Sascha is basically talking to us through Twitch. Okay. Yeah, see, like I have to work on like, because I know cosine and sine are like more like wave type equations. Well, not wave, it's not like the wave equation from partial differential equations, but I know that they have a wave-like quality to it, so I know it's going to be something that involves like either dissipating wave or something involving like, you know, just wave type of thing. It deals with change in time. So it deals with the change in time. It could be, yeah, it could be that, yeah. Let me come on Twitch. Oh, okay, no problem. Any equation of physics that involves the Laplacian on a rod or one-dimensional domain. Oh, okay. Yeah, what did they did in the solution here, actually? I want to see what they did. Wow, there's a lot of steps here. Okay, so the way they wrote it is that y is equal to a constant sine minus a half x. Well, so they solved for lambda in that way. I mean, the way we did it before, I mean, that pretty much is the same when you think about it, when we actually just turn it into a fraction. Like one whole fraction, I think. But where did they get this? Oh, maybe it's because of the square root? Could be that. But very interesting. Very interesting. Okay. Well, that one was pretty tough. Let's try another one. I think this might be the last one we try on stream. So maybe we'll try number 10 since we kind of struggled with number 9. So okay, number 10. Oh, hello, Dirty Pony. 2216. Interesting name. Interesting name. Oh, okay, okay. Welcome into the Twitch chat. And if you guys like math, physics, or just like need a study stream to keep yourselves productive on your computer, consider dropping a subscribe if you're watching this on YouTube, or a follow on Twitch. And thank you for the follow, Dirty Pony. I'm from the US. May I ask where you're from? Okay, so we have about the same thing here, where it's like plus meaning that you're gonna get so this means Ethiopia. Oh wow. I don't think I've ever talked to anyone from Ethiopia before. Welcome, welcome, welcome in. Because I'm so used to people from India like coming onto my live streams. Wow, like today we're actually meeting like I met like 2 people, including yourself, from Africa. That's cool. Yes, it's a third world country with limited internet access. Well, I'm glad you're here. I'm glad you're here. Yeah, because I think on YouTube, I was talking to someone from dang, I'm forgetting the name. Tunisia? Tunisia? I'm trying to pronounce it right, that's why. I don't want to mispronounce countries. If I'm mispronouncing it, please let me know. I want to make sure that I address your countries as well as yourselves properly. What grade of math is this? Well, I'm just doing math as a hobby, so if you're in university, it would probably be like maybe in your... If you took calculus in high school all the way up to calculus 2, then I think in university this would probably be on your 2nd semester, because it's differential equations. Okay, so now we don't have a real part, so we're left with the same one we had before, cosine and then plus sine. So the boundary conditions we have, it's practically this. Oh, it's the reverse. So this one is 0, and then this one pi is equal to 0. So probably 2nd year or 1st year of university. Right. Because usually I know classes, they go by semester, so like if you have to take like multivariable calculus in 2 semesters, like if you have to take multi-calculus 2 and multi-calculus 1, like if they split it up like that, because I know some universities do that, but usually I'm so used to like, you know, probably 1 semester is like multivariable calculus and another semester would be differential equations. But actually, Dirty Pony, like, are you in university right now, or are you just like math, like doing math as a hobby, or are you in grad school? I think education is rewarding in the U.S., right? Like learning in the U.S., like school is expensive. Like universities, they are expensive. But like you do, like I think like the education system is still like, you know, considered like the top here, but it's a lot of hard work, like especially in university, because I think in other countries university is not as stress inducing, I think, but don't quote me on that. I just think in the US school is just like university is just too expensive. No, I dropped out of from university, but I do math and physics as a hobby. Freelance as an AI engineer. Oh, that's cool. I never even worked with AI, so you're ahead of me in that. So I'm glad you're here. Like, you know, if you love math and physics as a hobby, you know, you're more than welcome to join us. That's what this channel's all about. School doesn't allow creative freedom here. Yeah, I agree with that too. Because universities in the US, they love to popularize themselves as like, oh, come to our university and you're guaranteed a job. And I think universities or any educational institution has to stop doing that. I think basically the only reason you go to university is to educate yourself or go to grad school. I think that's the only reason you should go to university. Period. Of course, like many companies, they still require a bachelor's degree, but I think now they're trying to roll back on that. So now I think a lot of corporate jobs that don't require a college degree, they're trying not to make that a requirement. But I think still some top-notch companies still want people from university to work for them. Like, you know, they want office workers to be from college. They don't want them to be from high school. But I have 30 days to complete stuff since I'm paying. Oh, let's see. I want to make sure that I didn't miss anything. But the average wage, oh wow, per month. Technically, I'm in college. You count my room as a classroom. Well, technically, the room I'm in, which is technically the house office, that would be my classroom then. But I have 30 days to complete stuff since I'm paying $60. In my universities, we have computational course ODEs and PDEs in the 4th semester. 5th semester is more PDE, and 6th semester is theory of ODEs. Oh, okay. I think it depends on the school. Yeah, it depends on the school. Okay, so let's take the derivative of this. So then we have a negative sine of dot. Okay. Alright, so this time in the derivative, 0 will lead to 0. So that would mean that b, in this case, b has to be equal to 0. We'll just do what Sascha did, just basically oh, whoops, wrong one. It should be on this one. B is equal to 0. Gotta make an outside office since I don't have as much room here. Just gotta invest in a clear tarp and protect from the weather from the table outside. That's fair. Yeah, that might be a fun project to do. So this will be 0, and then we have 0 equals sine of theta x. But once you know calculus, you can do the first two classes. The theory required is a bit more knowledge of analysis, right? How do you find the curiosity to pursue theoretical mathematics with minimal real-world problem in the questions? That's a really good question, Dirty Pony, because math itself is more like a puzzle when you think about it, because it's mainly about patterns. So I think like the fun thing about math, if it doesn't have real world applications, is when you ask yourself, like, what does the definition of something mean? So when you think about even numbers, for example, even numbers are just like, you know, any number times 2, right? So we'll define this as an even number. Whilst an odd number, we would have like an even number plus 1. And the thing of it is that what interests people in math that doesn't involve physical applications or any applications in anything in life is that what would happen if you let's say if you add these together, right? You're analyzing the behavior of what would happen. So we're adding an even number plus an odd number. Now I know it's very simple, and I think a lot of people would find this very like too simple, but I think it's like a good way of just introducing something that makes math interesting to people. It's that, so like in regular arithmetic, we would add these together, so it would be 4n plus 1. And then like you have to figure out exactly, okay, so what is this new number we made, right? So, and the question is that how can we turn this into a number that we know, which is even or odd, right? So I think one thing we can do is just take out the 2 here, because nothing's preventing us from doing that. But then let's say if we turn that 2 into a k, so then it would be 2k plus 1, but then that looks similar to what we had for an odd number. So usually mathematical proofs are involving stuff like that, like mainly behaviors. Now this is probably like a very terrible example, but this is something that I think is kind of like introduces why people get into math without you know, like physical applications or anything involving like physics or like economics or something like that. I mean, hopefully that answers your question. So you see it as a mental exercise to figure out patterns. Yeah, because mathematics itself is basically I guess like I read this in a book. I like the way this is phrased. We look at math as sort of the science of patterns, but if you don't want to make math a science, you can think of math as sort of like the logic of patterns, or the creativity of patterns, whichever you want to prefer it to as. Because math itself is just as much as art as it is a logical exercise. Yeah, hopefully that helps. Hopefully that answers your question. I mean, that's the only way I can think of saying math is interesting, because of that reason. I'm always drawn to patterns. Yeah, I think a lot of people are. A lot of people are drawn to patterns. So yeah, b would be 0, and then we're just doing this. Okay. Now, if sine, so if a is 0, then that's going to be boring. So if sine is 0, and we have 0 here, so then practically that doesn't give us theta at all. So then if we have y equals x is equal to pi, like in this one, then that would mean that a is 0, which doesn't help us actually. But then again, it's probably going to be equated to the same thing we had last time. Because I remember what Sascha did before. It's like, what was it? It's like pi over 2. Oops. Pi over 2 plus n pi. And technically, x is supposed to be pi in this case. So I feel like it's going to be the same thing. Just going to be written differently, I think. So then y in this case, if a is supposed to be 0, then we don't know what b is. But that would just leave us with sine. I mean, practically it's practically the same, like the first one, I think. Unless it's the opposite, let me see. Because then if we have pi there, then yeah, then this would have to be 0, because that one leads to 0. So if we had 0 in the derivative, and then this is 0, and this is equal to pi. What does lambda represent in this question? Is there another variable? So lambda represents the eigenvalue right here, because we have to figure out what lambda is, and then once we figure out what lambda is, we can just basically incorporate it in the function that we want to solve for, or at least like the equation that we want to get from this differential equation here. Let's see here, because it feels like it's similar to this question, but I don't know if it's the exact same. Like, they're not the same question, but they are, like, the way their pattern looks, it looks similar. So this one's cosine. Interesting. Because this one has to be pi, and when this is pi, this goes to 0, right? Yeah, so, oh, okay. I mean, yeah, that should work. These problems I might have to practice more a bit. But yeah, because I think it's because of the eigenvalues, I have to actually know how the pattern works. Because like once I get the pattern working and like actually see what I'm supposed to see, then I'm like, okay, I should be able to understand it a little bit more. Okay guys, that will do it for today on the MathSpellBook live stream. Hopefully you guys enjoyed, or hopefully you guys got some work done. If you were just doing some work, like while I was doing some problems myself. Let's see, for the reasons I never understand, I'm usually lazy and dense when it comes to theoretical math. I mean, I'm the same way, because like with proof-based math, it takes me a lot longer to solve things. Like one of our friends in the Twitch chat, Sascha, he's taught me a little bit of real analysis, and whenever I try to do a mathematical proof question, it takes me like more than 20 minutes to try to understand it, and sometimes I never understand it at all. Like usually when I try to do proofs on this stream, I take much longer, and sometimes I leave the board blank because I'm just trying to figure out exactly how to organize my thoughts at that point. So like don't feel bad. Like if you think you're being lazy, I probably feel like I'm being lazy too. Like I feel like I'm not putting enough effort as I should. Which is why I made this channel, because it allows me to which motivates me to work more on math and stuff. Yes, I do have a schedule. It's actually in the about section. I usually, for the MathSpellBook channel, I usually stream from Monday, Tuesday, and Wednesday, so 3 times a week. But I also stream on my gaming channel as well. So but yeah, thank you guys for joining me today, whether you're watching this on YouTube. If you're watching this on YouTube, consider dropping a sub. I would really appreciate it. In addition, like, you know, hit the like button, as well as leave a comment down below if you can. No, I am not a teacher. I just love math as a hobby, so when people ask me like questions that I can answer, I just try my best to answer it. But if it's something that's way above my knowledge of math, then I just basically just like say that I can't answer it because I've never learned that subject. But yeah, if you're watching this on Twitch, you know, drop me a follow. I really appreciate it. It keeps me motivated to keep making more live streams for you guys, in addition to just, you know, just doing more problems. And it also helps me motivate me to like read more outside of stream, so more math like research on my part whenever I do these streams. So yeah, so thank you guys for chilling with me, And also in the links down below, if you're watching us on YouTube, we have our links to our Discord as well as my gaming channel. So like on YouTube, my Twitch channel is also in the description down below. And I think my YouTube channel is linked into my Twitch. So yeah. Well, that will be it for today, guys. And always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys in the next stream. So take care, guys. Bye-bye.